7 f of t dt equals 0, which of the following could be a table of values for the function f?
So if f prime is positive, so here's my PVA card. If f prime is positive, the graph is strictly doing what? Increasing. So we know the graph is increasing. So let's start off with that one. If the graph is increasing, as my x is going up, my y must go up. That is true. Is that true for part B? As my x increases, y also increases. Okay. What about C? As x increases, what happened right here, right? It went down all of a sudden, so we know C is not it. And D automatically is a what? It's a no, because if I have 0 all the way through, that's not increasing. And then for E, as my x is going up, my y is going up. Y'all good with that? Okay? So then, for the area to be 0, it's going to look something like where I have the same amount of area on the top and same on the bottom, because they negate each other, correct? Okay? Because it's strictly increasing, you don't want to waste time with the middle one. And I'm going to model the one that doesn't work and one that does work. Let's go ahead and graph this guy over here. So if I graph this, it's going to give me 4. 4, negative 4 is going to be somewhere over here. 7, 0 is somewhere over here. And when I graph this, isn't the area always negative under the x-axis? So we know it's not going to be 0. So automatically that's not right. And let me show you why B is correct. When I sketch this, B is at 4, negative 4. And then we have 4, negative 4. I'm just going to guesstimate right here. And 7, 5. So 7, 5, guesstimate somewhere over here. And as long as they're strictly increasing, we know we have area on the bottom, area on the top, and most likely when I add them, they're going to negate. Are we good with that? So it's got to be this one. If you test out the E, it's not going to work out because it's all above the x-axis, which is strictly positive. Okay? Now let's go on to the next one. And go ahead and score yourself. Can you get this as a raw score? Could you potentially get it in the future? Okay, 87. Andrew, let's read.
The graph of f, the second derivative of f, is shown above for negative 2 is less than equal to x, less than equal to 4. What are all intervals on which the graph of the function f is concave down?
Okay, concave down. Let's see what is happening. So I gave you the second derivative, and I'm looking for when it's concave down. So it's concave down when f double prime is what kind of sign?
Negative.
Negative. So I'm going to go to my graph. Because this is my double prime, I'm looking for negative here and negative here. So we're going to go from negative 2 to some number over here. It looks like if I were to kind of guess negative 1, 1 to 3, which one has that answer choice? Which one? Would y'all agree it's E?
Yep.
Yep, done. Moving on to the next one. Okay, 88 is our related rates. So Lauren's going to go ahead and read that one.
A person whose height is 6 feet is walking away from the base of a street line along a straight path at a rate of 4 feet per second. If the height of the street line is 15 feet, what is the rate at which the person's shadow is lengthening?
Okay, so this related rate is very, very doable. Let's see why that is the case. Y'all remember the acronym FWIGI? Sounded kind of funky, but it was a way to kind of remember. Okay, the hardest thing in my opinion is finding the equation. An equation is simply applying geometry with proportion. Let's see what I mean by that. We're looking for what is the rate of the person's shadow lengthening. So we have to kind of put variables. I'm going to let, first of all, the pole is right angle. From the pole to the person, let's let that be x. From the person to the tip of the shadow, let's call that y. And I'm going to write on here shadow. And what's nice is the shadow is kind of bolded in case you can't picture it. And then go ahead and complete your hypotenuse. So how many right triangles do I have here? I have a small one on the right, and as a whole, I have a big one. Do we all see that? Okay? And it says a person is how tall?
6.
So it's saying my height is 6. And then also we have the height of the pole. How tall is a pole? 15. Let's put that in. 15 and 6. And we're looking for the person's shadow lengthening. The shadow is lengthening. That's dy over dt. And they gave us some other rate. It says the straight path at a rate of 4 feet per second. So that's going to be dx over dt. It's 4 feet per second. Okay, the equation is the hardest one that I told you to find, and it was simply our direct proportion from geometry. Here's my big triangle and small one. In my small one, I have 6 to y. In my big one, I have 15 to x plus y. Are we good on that so far? Good? Okay, let's make our proportion. So I have 15 over x plus y is equal to 6 over y. And when I cross multiply, I get 15y is equal to 6x plus 6y. And then when I move the y over, we get 9y is equal to 6x. Are we good on that so far? So when I go ahead and solve for y, our y is going to be 6 over 9, which is going to be simplified to 2/3 x. And that is our equation, 2/3 x. So now let's go ahead and derive implicitly. So derivative of y is 1, dy over dx. Derivative of the constant x is that constant, dx over dy, or dt, silly me. These are all t's, by the way. It's with respect to time. And let's see what I know. Didn't I give you dx over dt? Is that a yes? Okay, so when I multiply that by 4, that's going to give me 8 over 3. Let's type in 8 over 3 on the calc. And maybe you don't need to type in because it's most likely what letter?
B.
B it is. Very good. So as long as you know where the variables go, you're good to go on this one. Okay?